Welcome back. Today's explainer is all about demystifying profit and loss. Now, you might be thinking, hey, I already know how to subtract. But trust me, we are taking this way beyond the basic mechanics today. We'll start with the foundational building blocks, sure, but then we're going to uncover a literal cheat code hidden in the material that completely bypasses those clunky, time-consuming calculations. Here's our game plan for today. First, the language of business. Second, calculating the percentages. Third, core formulas in action. And finally, number 4, the pro-level shortcut. All right, let's jump right into section 1, the language of business. So, how do we actually measure business success? It really comes down to the space between buying and selling. That's where success is made or broken. And we've got 3 absolutely crucial terms you need to lock in. First up is CP, or cost price. This is literally the price at which an article is purchased. Think of it as your starting line, your baseline investment. Next, we've got SP, the selling price. This is the exact price at which an article is sold. It represents that finish line, the moment the transaction is actually completed. And finally, MP, the marked price. This is that literal price tag you see written on the article by the shopkeeper. It's what they want you to pay, before any haggling or discounts actually happen. And understanding those terms sets up the whole shebang. It's pretty simple. If your selling price is greater than your cost price, boom, you profit. But if the cost price is higher than what you sold it for, you're taking a loss. Moving right along to section 2, calculating the percentages. Okay, let's rapid fire through a real-world scenario. Let's say you buy an article for 500 rupees. That's our cost price. You sell it for 600 rupees, our selling price. Subtract that 500 from the 600, and you've made a cool 100 rupee profit. But how do we turn that into a percentage? Easy. You take that 100, divide it by your original 500 investment, and multiply by 100. And that gets us a solid 20% profit. Translating raw numbers into percentages like this gives us a universal metric. It lets us truly measure how efficient a deal was. Now, let's look at the flip side and contrast that with a loss scenario. Imagine your initial cost price is 800 rupees, but the selling price only ends up being 680. That's a raw loss of 120 rupees. To find the percentage, put that 120 over our starting 800, multiply by 100, and that calculates out to a 15% loss. It definitely stings, but hey, the math doesn't lie. Let's kick it up a notch. Section 3, core formulas in action. Now, what if you know your target profit percentage? We'll call it P for now, but you need to figure out how to price your item. Well, to find the selling price, you multiply the cost price by 100 plus P, all divided by 100. And if you need to work backward to find the cost price, you just flip it. Cost price equals the selling price multiplied by 100 all over 100 plus P. Let's put a little story to this to see it in action. Imagine an article is sold for 720 rupees. You know for a fact that a 20% profit was made on this sale. So, what did it cost originally? Let's plug it right into our formula. Cost price equals 720 multiplied by 100 over 120. Do the math, and we can guarantee the original cost price was exactly 600 rupees. And you know what? The exact same formula logic applies perfectly to a loss. Say an article is sold for 680 rupees, resulting in a 15% loss. What was the original cost price? Well, we multiply 680 by 100 over 85. Because remember, it's 100 minus that 15% loss. Run the numbers, and we get our original cost price, 800 rupees. All right, section 4, the pro-level shortcut. This is where things get really fun. Listen, if you're taking a highly competitive, timed exam like the SSC, or you're just trying to make a split-second business decision, you literally do not have time for long algebraic fractions. The absolute game changer here is the ratio method. This bypasses all those clunky formulas entirely by converting your percentages directly into ratios between the cost price and selling price. Think of these mappings as your ultimate cheat sheet. Notice how common percentages map instantly to simple ratios. A 10% profit is a 10 to 11 ratio. A 20% profit instantly means the ratio of cost price to selling price is 5 to 6. Or take a massive 50% loss. That just means a 2 to 1 ratio, right? You spent double what you made. Grasping these is like seeing the matrix. You instantly understand the underlying mathematical architecture. Let's see just how blazing fast this method is in action. Say an article sells at a 20% profit, and the actual cash difference between the selling and cost price is 100 rupees. Well, using our cheat code, a 20% profit is a 5-to-6 ratio. The difference between 5 and 6 is just one part. So if one part equals 100 rupees, we just multiply. Cost price ratio of 5 times 100 is 500 rupees. Selling price ratio of 6 times 100 is 600 rupees. Instant answers, no cross-multiplying required. So I'm going to leave you with this thought. The next time you're staring down a ticking clock on a standardized test, or you're trying to negotiate a deal on the fly, if you had just 30 seconds to solve a complex 40% loss scenario, how much faster could applying that 5-to-3 ratio get you to the finish line? You've got the tools in your hands now to completely change how you calculate success. Thanks for joining me for this explainer, and I'll catch you next time.
So let's just dive right in. Here's a quick look at our agenda for this explainer. First up, we're going to uncover something called the profit percentage trap. After that, we'll expose the secrets of dishonest dealers. In part 3, we're going to completely shatter that illusion of storefront discounts we just talked about. Then, we'll explore some seriously mind-bending profit and loss paradoxes. And finally, we will wrap the whole thing up with the ultimate math shortcut. Honestly, it's a literal cheat code for exams and for real life.
All right, part 1, the profit percentage trap, cost price versus selling price.
Okay, so this is where the very first wrong turn usually happens. We naturally assume that profit is always calculated based on what an item originally cost. But the math shifts dramatically depending on your base number. Let's say a merchant buys something for $100 and they want a 20% profit. They make $20, sell it for $120. Super simple, right? That is a straightforward 20% profit on the original cost. But watch what happens if they decide to calculate their profit as a percentage of the final selling price instead. That same $20 in profit is now divided by the new selling price of $120. And 20 divided by 120, that gives us exactly 16 2/3%. The exact same financial transaction looks fundamentally different just because of the base number used. This is a classic, sneaky trap they love to lay out in competitive exams just to test your attention to detail. So, your crucial takeaway here is knowing exactly how to reverse engineer this trick. If you are ever faced with a profit that's explicitly expressed as a percentage of the selling price, here is how you undo it. The cost price equals the selling price, multiplied by 100 minus the profit percentage, all divided by 100. It's like magic. It just effortlessly peels back that layer of the selling price and reveals the true cost underneath. Definitely memorize this one. It is going to save you some serious time.
Moving right along to part 2, secrets of dishonest dealers and the false weight trick.
We are now dealing with the absolute villains of the retail world, and we need to talk about their most notorious weapon, 800 grams. I want you to lock this specific number in your brain. When a shady shopkeeper acts like they're selling you a full 1 kilogram, 1,000 grams of goods, this is very often the actual weight they are secretly slipping onto the scale. Let's play this scenario out. They look you in the eye and tell you they bought 1 kilogram for 100 rupees. And hey, because you're such a great customer, they're selling it to you at cost for 100 rupees. 0% profit, right? Well, no way. They only actually gave you 800 grams. And the cost to them for those 800 grams was only 80 rupees. But remember, they still charged you the full 100. So they just made a 20 rupee profit on an 80 rupee cost. 20 divided by 80 is 1/4, meaning their actual hidden profit is a staggering 25%. And this brilliantly illustrates the general formula you can use for literally any false weight scenario. The profit percentage equals 1,000 minus X, where X is the actual grams they handed over to you, divided by X times 100. Notice how the denominator at the bottom is the actual weight given, not the 1,000 grams they promised. Why? Because the dealer's actual baseline cost is based only on the physical goods that actually left the store. Okay, but what if our dealer isn't just dishonest, but openly greedy too? Let's say a shopkeeper boldly marks up their goods by 20% right off the bat. So step 1 is a 20% base profit. But then, step 2, they also use that false 800-gram weight on the scale, which, as we just learned, secretly adds another 25% profit. So what's the total? If you're thinking 45%, think again. Deception compounds. Mathematically, it's a multiplier effect. You take their price markup of 1.20 and you multiply it by the weight ratio.
which is 1,000 over 800. 1.2 times 1.25 equals 1.5. Step 3, this dealer is quietly walking away with a massive, compounded 50% total profit. Crazy, right?
Okay, part 3, the illusion of discounts, marked price, and successive discounts.
This whole concept is all about the marked price. Honestly, it's a sticker price that's largely invented just so it can be visibly slashed to make you feel good. And the single most powerful psychological tool they use here is the successive discount. You've seen the signs. Huge sale, 20% off, plus an extra 10% off at the register. Your brain instantly does the easy math and thinks, wow, 30% off. But let's break it down. If the original marked price is 100%, that first 20% discount brings the price down to 80%. But that second 10% discount, it doesn't apply to the original 100. It applies to the new, lowered price of 80. And 10% of 80 is just 8. So 80 minus 8 brings us to 72%. Your total discount is absolutely not 30%, it's exactly 28%. The retailer just brilliantly made you feel like you were getting an amazing 30% deal, all while quietly keeping an extra 2% right in their pocket.
Now, if you want to instantly solve this in your head without drawing out a whole chart, just use this formula. The equivalent discount of two successive discounts is simply A plus B minus A times B divided by 100. So, in our mall example, 20 plus 10 is 30. Then minus 20 times 10 over 100, which is 2. 30 minus 2 equals 28%. It's fast, it's completely accurate, and it makes you totally immune to that storefront marketing magic.
And the beautiful thing about this formula is how flexible it is. It adapts to any chain of events. Need to calculate a net successive profit or loss? It uses the exact same skeleton structure. You just plug in a plus sign for profits or price increases and a minus sign for losses or discounts. So, for example, if an item sees a 20% profit, but then is followed by a 10% loss, you just plug it in, positive 20 minus 10 minus the result of 200 over 100. The end result, a net 8% profit.
Part 4, Profit and Loss Paradoxes. Same selling price versus same cost price.
All right, this is where human intuition totally fails us and the math reveals a major trap. What happens when two items are sold under seemingly identical conditions, but you get completely opposite results? Let's say you buy two items for exactly the same cost price, say 100 rupees each. You sell one at a 20% profit and the other at a 20% loss. You make 20, you lose 20. Overall result, no profit, no loss. You simply broke even. But, and this is a big but, look what happens if you sell two items for the exact same selling price, say 1,000 rupees each. Again, one was sold at a 20% profit, the other at a 20% loss. Most people will instantly guess it's a break even again. It is absolutely not. When the selling price is the same, having an identical percentage of profit and loss always results in an overall loss. Every single time. The formula to find out how much is just x squared divided by 100%. So 20 squared is 400. Divided by 100 is 4. You didn't break even, you just suffered a 4% loss across the entire transaction.
Before we get to our final grand shortcut, let's set just a couple of quick ground rules for avoiding those really careless exam mistakes. First up, the actual cost price isn't always just the base purchase price. You have to remember to add any overheads, things like transportation, repairs, labor. Add all of that before you even start calculating your profit. Second, when you are dealing with multiple items, always compare the total selling price to the total cost price. Never try to average out individual percentages across items unless a question explicitly forces you to. It's basically a guaranteed way to get the wrong answer.
And finally, Part 5, the ultimate math shortcut, the playbook's master key. Listen, if you take away just one single thing from this entire explainer for your next competitive exam, make it this master key. Whenever only percentage information is given, take the cost price as 100. I know, it sounds almost too simple to be profound, but I promise you, this is the ultimate cheat code. When these word problems throw a massive barrage of percentages at you without giving you a single, concrete currency value to work with, do not use X. Do not start building out complex algebraic equations. Just assume the cost price is 100.
Let's actually look at how this builds a super clear path through a really tricky problem. Imagine a question says, an article is sold at a 25% profit. If the selling price is then increased by 20%, what is the new profit percentage? If you try to use algebra here, it is an absolute headache. But applying our master key? Well, just assume the CP is 100. That means the old selling price with a 25% profit was simply 125. Next, the problem says that SP increases by 20%, so you just multiply 125 by 1.20. That gives us 150.
Our new selling price is 150, our base cost price is still just 100. 150 minus 100 is 50. The new profit is exactly 50%. By grounding all those abstract percentages in the number 100, we just turned a complex algebra problem into basic mental arithmetic. It's amazing.
Well, we have definitely covered a lot of ground today. From the sneaky traps of calculating profit on selling price to the crazy compounded deception of false weights on the scale. It's honestly kind of wild to finally have the math to see right through the glass, isn't it? So, I'm going to leave you with this final thought. Knowing everything you know now, who is really winning the next time you see one of those flashy, successive discount sales at the mall? Keep calculating, keep questioning everything.
Thank you for watching this video. So see you next time. Bye bye.